Periodic classification of elements. Let us study modern periodic table. As more and more elements and their isotopes were discovered, Mendeleev's periodic table that gave a chart of all the elements was found to be inconsistent in many ways. Henry Moseley found the reason for this inconsistencies. Moseley revised the periodic table and he suggested that instead of arranging elements in ascending order of their atomic masses, they should be arranged in ascending order of their atomic numbers. The modern statement of periodic law is that the properties of the elements are periodic function of their atomic numbers. Niels Bohr prepared the present version of periodic table. The features of periodic table are: the table is divided into periods and groups. Periods. Table consists of 7 horizontal periods. The element of the first period consists of 1 shell. The element of the second period consists of 2 shells. The element of the third period consists of 3 shells, and so on. In short, the period number symbolizes the number of shells the element has. In the second period, for example, as we move from left to the right, that is, from lithium to neon, the L shell gets filled progressively. Similarly, for the third period, the M shell gets filled. Now, we move on with the groups. Groups. The vertical columns are called groups. There are 18 groups in the periodic table. Group is about
valence.
Elements in a group have the same number of
Valence
electrons. The chemical properties of the elements are determined by their valency electrons. Hence, elements in the same group have similar properties. Let us consider an example. Elements of group 1 contain 1 valency electron. These elements can easily lose this electron to form a positively charged cation, such as sodium, potassium. Similarly, elements of group 2 have 2 valency electrons and can lose both these electrons to form a dipositive cation. Example: calcium and magnesium. On the other hand, the element of group 17 have 7 electrons in the outermost shell. It is easy for these elements to accept 1 electron and thus form a negatively charged anion. Example: fluorine, chlorine, and bromine. Group 18 elements have their octet state complete. Hence, they are inert or unreactive. Elements of group 18 are called as noble gases. Positively charged species are called cations. Negatively charged species are called anions. The periodic table is divided into 4 blocks based on electronic configuration. The modern periodic table is approximately divided into metals and non-metals. The most metallic elements, such as alkalis, are on the left-hand side. The non-metals are on the right-hand side. The inert gases or the noble gases with their completely filled electronic shells are placed on the extreme right-hand side. The transition metals, which are the bridge between highly metallic alkali elements and non-metals, lie in the center of the table. Lanthanides and actinide series, which have metal-like behavior, are kept separately as their outer electronic configurations differ from the transition metals.